Hello, my name is Marin Andrijašević. I'm working as an approach ATC instructor at Croatia Control. Today we are going to demonstrate how to safely and efficiently resolve the traffic situation for the given airspace. In our example, actually it's a Langen airspace. First of all, we need to set the resolution screen to see the whole airspace, so we are setting it to 85 miles. Now we can see the whole airspace we are working with. Secondly, we need to familiarize ourselves with the airspace. To do so, we will study the arrival and departure procedures. All the arrival procedures via inbound points Kolas, Rasvo, Xinla, Sirpo, Olali and Kerax, and departure points for runway 07 at Langen. All of that will help us to know which routes aircraft are following during arrival and departure procedures, so we can see and understand certain points of conflicts during arriving and departing traffic. Also, we will measure the distances and headings from the entry points to the final approach fix. In our case, final approach fix is ATCOSIMA point. How do we measure that? We can take first point Kolas and just put the line inbound Kolas and measure that it's approximately heading of 150 and distance is 55 miles. All the other inbound points we can do the same, also to measure the distances and headings inbound final approach fix. We are doing that to familiarize ourselves with the airspace distances and times each aircraft has to pass until reaching final approach fix, and in overall it helps us to make proper sequencing of arriving traffic. In this particular exercise, arrival traffic will be at flight level 220 and the approach altitude at final approach fix should be 3000 feet. All departing air traffic from Langen Airport is climbing initially to flight level 60, so transitional altitude is 5000 feet with QNH set for today's exercise 1015. Now that we are familiar with the airspace we are working with and procedures, we can start with the exercise. Langen radar radio check.
Radio 5,
Radio 5, we can start with the exercise.
starting. Langen radar Turkish 355, airborne climbing to flight level 60.
Turkish 355, Langen radar identified, climb flight level 250.
Climbing to flight level 250, Turkish 355. Langen radar Turkish 19901, inbound Rasval maintaining flight level 220.
Turkish 19901, Langen radar identified, expect ILS approach runway 07.
Expecting ILS approach runway 07, Turkish 19901. Langen radar KLM 1113, inbound Kolas maintaining flight level 220.
KLM 1113, Langen radar identified, leave Kolas heading 155, vectoring ILS approach runway 07.
To leave Kolas heading 155, vectoring for ILS approach runway 07, KLM 1113.
Freeze. Now, first of all, we can now see that there are coming lots of inbounds for the airport. First thing we do in sequencing the aircraft, we measure each aircraft on the final approach fix and patched to each one like this. Why are we doing that? Actually, we now see that the distance of KLM1113 is 63.3 nautical miles to final approach fix, and the distance from Turkish 1901 to final approach fix is 68.1 nautical miles. We see in the label that both aircraft are the same type, Airbus 320, and which is more important, they are maintaining the same speeds. So with this given speed, KLM1113 has approximately 5 miles less to travel to final approach fix, so it will be number 1 and Turkish 1901 will be number 2. If we have a situation, if the KLM is slower one and this one is faster, then we have to calculate at which time they will be at final approach fix. If we want to resolve that problem, because they are both the same types, we can increase speed of KLM 1113 and reduce the speed of Turkish 1901 to make separation and sequencing like this. So KLM 1113 will stay number 1 and Turkish 1901 will be at number 2. If we have a problem of a different type of aircraft which is not fast as this one, then we have to calculate, does this one will be number 1 with given speed, so we can increase speed of this one and we can reduce speed of this one to make him number 2. It all depends on the aircraft type. At this situation, with the same aircraft type and the same speeds, KLM 1113 is number 1 in front of Turkish 1901. It has approximately 5 miles advance in front of the Turkish. Next, what we do, we have the Sun Express 6996 and Cargolux 122, which have to measure between both of them, and Cargolux 122 we have to measure between Turkish 1901 to establish the proper sequence. So we are using the third QD mic to patch the final approach fix and to Cargolux 122, and the fourth QD mic to patch final approach fix with Sun Express 6996. As we can see now, Turkish is evidently in front of the Cargolux 122, also aircraft the same types. Sun Express is behind Cargolux but only 2 miles, so we will have to do something about 2 of them. We have few solutions with the headings and with the speeds. We will see later about that, how the situation will develop. So initially, the sequence for the incoming traffic we see will be KLM 1113, then Turkish 1901, then number 3 Cargolux 122, and number 4 Sun Express 6996, and behind coming Lufthansa 474, which is the same aircraft type as all the others. Another thing, there's one more aircraft coming to Kerax, Santurk 404. We can use also a QD mic to measure his distance to final approach fix, which is actually a little bit smaller than the inbound traffic, but the point is that Santurk 404 regarding its position will travel a longer way behind to make the approach. So we can take a QD mic and measure approximately Santurk 404 path, and you will see that we have approximately almost 80 miles, which is almost the same as this one. So for time being, we will decide that KLM will be number 1, Turkish number 2, Cargolux 122 number 3, Sun Express 6996, Lufthansa 474, and then Santurk 404. The next thing we have to monitor are departures. So we have departed Turkish 355, routing to Rasvo. Routing is like this. We have to see is there any conflicts with the inbound traffic. We have to watch out the given rate of climb for each aircraft and rate of descent for the inbound aircraft. Also, the other aircraft departed runway 07 is Sun Express 663. Also same routing as Turkish 355. Also the same type. We have the proper distance between them. So we have to watch and monitor the speeds of Sun Express and Turkish 355 and the rate of climbs. If needed, because of the separation along the routes, we'll change the speeds or maybe the rate of climbs. Both of them will climb to flight level 250. Now we can continue, unfreeze, free.
Langer radar, Sunturk 404, inbound Kerax, maintaining flight level 220.
Sunturk 404, Langen radar identified, leave Kerax heading 245, vectoring, ILS approach, runway 07.
To leave Kerax heading 245, vectoring for ILS approach, runway 07, Sunturk 404. Langer radar, Sun Express 663, airborne, climb to flight level 60.
Sun Express 663, Langen radar identified, climb to flight level 250.
Climb to flight level 250, Sun Express 663. Langer radar, Austrian 423, inbound Olali, maintaining flight level 220.
Austrian 423, Langen radar identified, expect ILS approach, runway 07.
Expecting ILS approach, runway 07, Austrian 423.
KLM 1113, descent to 5000 feet, QNH 1015.
Descend to 5000 feet, QNH 1015, KLM 1113.
Turkish 1991, descent to flight level 60.
Descend to flight level 60, Turkish 1991. Langer radar, Sun Express 6996, inbound Rasmo, maintaining flight level 220.
Sun Express 6996, Langen radar identified, expect ILS approach, runway 07.
ILS approach, runway 07, Sun Express 6996. Langer radar, Sunturk 101, airborne, climb to flight level 60.
Freeze. Okay, the next situation is interesting. So what we did do in the beginning? So we gave a heading to Sunturk 404, which leads him to downwind, left downwind, runway 07. So departures to the left are clear of him. They will pass his trajectory early before. But the interesting thing is Sunturk 101 departure. Why is that interesting? We will take the tool and measure the distance between two of them. We have only 3.4 miles. Sun Express 663 is passing about just 5000 feet and Sunturk 101 is passing 2200 feet. We don't have the distance enough to make separation, but for time being they are separated with the altitude or the levels. But what must we do? We must ensure that Sunturk 101 would not catch the Sun Express 663 climbing through his altitude and breaking the separation. And also we have to monitor the route of Sunturk 101, which is going to Xinla Point, which is actually in conflict with Croatia 462 inbound Xinla and Croatia 591 from Sirpo to Lepsa and to Spessart. So at given time we have to resolve 2 or maybe 3 problems at once. So what should we do? First of all, we should ask the Sun Express 663 its rate of climb, and after that we will give him that rate of climb or higher, and when upon contact we will give the safe level for Santuk 101. For time being, the safe level is flight level 210 only. And then we can measure with the turn of Santuk 101 inbound Simla. What will we do with the climb? We can give, let's say, the middle level, let's say the flight level 120 or flight level 100, just to have enough airspace and levels for the incoming traffic, not to get high, because all the traffic high are fast. So first of all, we will ask the rate of climb of SunExpress 663. Then we will give rate to Santurk 101 and middle level, and routing maybe, if it's convenient, we will see. And then we will continue with the traffic. Unfreeze. SunExpress 663, report rate of climb.
SunExpress 663, 3000 feet per minute.
SunExpress 663, rate 2500 feet per minute or more.
2000 feet per minute or greater, SunExpress 663.
Santurk 101, climbed flight level 210, rate 2500 feet per minute or less.
Coming to flight level 210, 2000 feet per minute or less, Santurk 101.
Santurk 404, descent flight level 100.
Descent to flight level 100, Santurk 404. Radar Croatia 462, inbound Xila, maintaining flight level 220.
Croatia 462, landing radar identified, clear to Xinla, IBLUS next, ILS approach, runway 07.
Clear to Xinla, IBLUS next, ILS approach, runway 07, Croatia 462.
SunExpress 6996, descent to flight level 70.
Descent to flight level 70, SunExpress 6996. Langar radar cargo looks 122, inbound Rolex, maintaining flight level 220.
Cargolux 122, landing radar identified, fly heading 155, vectoring ILS approach, runway 07, descent flight level 80.
Flying heading 155, descending to 8000, correction to flight level 80, vectoring for ILS approach, runway 07, Cargolux 122.
Santurk 404, reduce speed to 250 knots.
Reducing speed to 40 knots, Santurk 404.
SunExpress 6996, reduce speed to 250 knots.
Reducing speed to 50 knots, SunExpress 6996.
Freeze. Now you can see from the radar picture, like I said before, SunExpress 663 within the turn is well cleared of Santurk 404, and that's actually the importance of knowing the arrival and departing procedures for you to know when the SunExpress 663 will turn left. Also, as I mentioned, we solved the problem between Santurk 101 and SunExpress 663. SunExpress 663 is now has a rate of 2500 feet per minute or more in climb, and Santurk 101 has 2500 feet per minute or less in climb. So both of them will be always separated during the climb because of the difference between the levels. Now Croatia 462 was instructed to go to Xinla and afterwards to IBLUS. That not happened, but we can correct it by measuring the heading, which is good for us, or from present position we can send direct IBLUS, or we can give the heading of 305, which is convenient for us. Actually it's almost direct to IBLUS. Why are we doing that? Because when this aircraft is turning left to this side, Santurk is free to go to Xinla and the conflict is resolved, and the other conflict between Croatia 591, which is not yet on our frequency, we also will be resolved with the instruction of maintaining the present heading. So we will have picture like this. Santruk will turn right to Xinla. Croatia 5901 will go on present heading, and Croatia 462 will be on heading 305 direct to Iblus, so the Santruk will pass in between. When the picture shows us that it will be clear, Santruk will be given final level of 250, and Croatia 5901 and Croatia 462 will be given descending level to be well clear of traffic between levels and a lateral level. Another thing we have to watch is the level of Turkish 355. Is it okay with KLM 113, Karagolux 122, and initially Lufthansa 474 and Sun Express 6996. All these aircraft actually are clear of this traffic, because when this aircraft passes, let's say next 2 or 3 minutes with the 1 minute vector, which is convenient for that to actually shows us at which place will be the aircraft in 1 minute. All of these aircraft will be under the altitude or level of Turkish 355 and Sun Express 663. All of that should be calculated during the arrivals and departures. If not, then we have to do something with the headings. Let's say turn the KLM to the right, Turkish to the right, or so on. But for time being, all the levels will be clear. So we got solved that problem. Now we can pay attention to the sequencing of this aircraft, what is happening. So we can do one more thing, actually to measure again that KLM is 42.3 miles from final approach fix. The Turkish 1991 is 50 miles from the final approach fix, and now we have to see actually distances from this one. So the plan is to put this one as number 3 or maybe number 4, because there's Croatia 462 coming also from Xinla. So what's the plan with these two, with this one and these two? From the picture we can see that the better plan is to take these two on exact same heading, like here, to give more space to those 2 or 3. But we have to watch about the headings and the levels they are passing, because at one time they will probably cross each other. So we must assure that the levels will be clear. So that's the main thing here. If we are going to cross above each other, they should be above. So the sequencing and doing sequencing is all about that. First aircraft in sequence gets the lower level, and then we are stack it along the sequence. Number 2 is 1000 above, number 3 1000 above number 2, and so on. So that's a rule. So we will now continue with the exercise and see what happens next. Okay, we are now continuing on freeze. Croatia 462, fly heading 305, descent flight level 120, vectoring ILS approach runway 07.
Flying heading 305, descending to 6000, correction to flight level 60, Croatia 462.
Sun Express 6996, maintain present heading, descent flight level 90, speed 250 knots.
Maintaining present heading, descending to flight level 90, speed 250 knots, Sun Express 6996. Long radar Croatia 5901, inbound Lepsa, maintaining flight level 220.
Croatia 591, Langen radar identified, maintain present heading, descent flight level 130.
Maintaining present heading, descending to flight level 130, Croatia 591.
Austrian 423, maintain present heading, descent flight level 130.
Maintaining present heading, descending to flight level 130, Austrian 423.
Lufthansa 474, descent flight level 100, speed 250 knots. Lufthansa 474, descent flight level 100, continue present heading.
Continuing present heading, descending to flight level 100, Lufthansa 474.
Okay, freeze. And now we have the next situation. So, the SunTurk 101 is well separated from SunExpress 663. So, we can turn off the distance between both of them. And as we can see by the instructions we were given to Croatia 591 and Austrian 423 and also Croatia 462, that all four of them were separated from SunTurk 101. How do you see that? We can again measure the track from SunTurk 101 to Xinla, and we can measure the track from Croatia 462 in heading 305. As you can see, in less than 1 minute they will be laterally separated, and with the given instruction of Croatia 591 and Austrian 423 to fly present heading, they could never meet. So the SunTurk 101 can be cleared to flight level 250, and Croatia 462, including Croatia 591 and Austrian 423, can be cleared to a lower level. So the problem of separation in this case of three of them and SunTurk 101 is solved. Then you can see that Turkish 355 is well cleared of all the other aircraft. It's well clear of the SunExpress 663 following the same route because of the speeds. Then we can switch Turkish 355 to Langen North frequency because it's not needed anymore to our frequency. We will wait a little bit with SunExpress 663, but approximately, let's say when it passes flight level 200, we can switch in also to Langen North frequency 120.150. Now, what to do next? We are keeping the sequencing of the aircraft. Number 1, number 2, like we said, maybe number 3 or maybe number 4, depends of Croatia 462. What is actually important of the other inbound traffic is to slow them down. At first they are slowed to 250 knots, then they will be slowed to 230 knots, and later on we will slow them to 210 knots. Why is this important? It's easier to work, we have more airspace, more time to do something with the aircraft which are slower, and it's easier to sequence the aircraft when are on slower speeds. So the plan now is to put Croatia 46 on this heading, eventually on heading 4 downwind. Also Croatia 591 and Austrian 423 eventually on heading to enter downwind. SunTurk 404 will now enter downwind, and these three will follow each other for the sequencing, and these two behind we follow behind to enter downwind in front of SunTurk 404. So that's the plan. The most important thing we should see and give are the levels of this aircraft. If they are flying above each other, so they will be very separated with 1000 feet. So we mustn't forget about that. So initially, the good idea for the last one in sequence, or these two last, to give them, let's say, higher level 100 or 110 or flight level 120, and later on, when the traffic situation clears, we will descend them accordingly to a safer level. So that's about that, and now we will continue in a moment with the exercise. Okay, we can continue. Turkish 355, contact Langen radar 120 decimal 150.
120 decimal 150, Turkish 355.
Turkish 1991, turn left heading 130.
Turning left heading 130, Turkish 1991.
Cargo looks 122, fly heading 170, reduce speed to 250 knots, vectoring ILS approach runway 07.
Flying heading 170, speed 250 knots, vectoring for ILS approach runway 07, cargo looks 122.
KLM 1113, descend to altitude 3000 feet, QNH 1015.
Descend to 3000 feet, QNH 1015, KLM 1113.
Turkish 1991, descend to 4000 feet on QNH 1015.
Descend to 4000 feet, QNH 1015, Turkish 1991.
Cargo looks 122, descend to 5000 feet on QNH 1015.
Descend to 5000 feet, QNH 1015, cargo looks 122.
Croatia 591, turn left heading 250, reduce speed to 230 knots.
Turning left heading 250, reducing speed to 30 knots, Croatia 591.
Sun Express 663, contact Langen radar 120 decimal 125.
120 decimal 125, Sun Express
150. Sunturk 404, turn right heading 250.
Turning right heading 250, Sunturk 404.
Austrian 423, turn left heading 250.
Turning left heading 250, Austrian 423.
Sunturk 101, climb flight level 250.
Coming to flight level 250, Sunturk 101.
Croatia 462, descend to flight level 70.
Descend to flight level 70, Croatia 462.
Croatia 591, descend to flight level 70.
Descend to flight level 70, Croatia 591.
Austrian 423, descend to flight level 80.
Descend to flight level 80, Austrian 423.
Sun Express 6996, turn right heading 180, descend to flight level 70.
Turning right heading 180, descending to flight level 70, Sun Express 6996.
Lufthansa 474, turn right heading 180, descend to flight level 80.
Turning right heading 180, descending to flight level 80, Lufthansa 474.
Sunturk 404, reduce speed to 210 knots.
Reducing speed to 210 knots, Sunturk 404.
Sunturk 101, contact Langen South 136 decimal 125.
136 decimal 125, Sunturk 101.
Freeze. Okay. Now we have this picture. So, the last departure, Sunturk 101, is solved, and we can switch him to upper frequency like we did. All three aircraft got lower levels, and they are now organized via the downwind for sequencing. And as I mentioned, we are organizing now this tree, this one, and the last two for sequencing. So we decided that this will be number 1, this will be number 2, this will be number 3 now, and Croatia 462 will be number 4. What do we have to do? So first of all, we have to measure the distance between number 1 and number 2. So we have actually the same speeds, 9.5 miles, which is good. We have to be careful about the levels of those two. They are cleared to a lower level, Turkish to 4,000 feet and Cargolux to flight level actually 5,000 feet. But we have to monitor the rate of descent of Cargolux 122 and Turkish 1991, because eventually Cargolux will fly over the Turkish. So if the rate is not good, if the levels are too close, then we have to do something with the rates like we did on the departures. For time being it's okay, because the difference is 3,000 feet between aircraft the same type, so it's good. But we have to monitor that. One more thing to do is to also measure up Turkish 1991 with Cargolux 122, because eventually on final we will have to have approximately, let's say, 6 miles to maintain separation. Then another thing to measure is the Sunturk 404. So approximately we will get him here, that's about 40 miles, and the one in front that will be is actually Sun Express 6996. As you can see, Sun Express will pass below Sunturk very early, so the most important thing with Sun Express and Lufthansa 474 is that both of these aircraft are below the Sun Express. So in that case we will slow down the Sunturk 404, but keep him high enough and watch the levels of these two. When the last one, Lufthansa 474, let's say is at flight level 70 or 80, then the Sunturk can get a lower level. So that should be considered. To get a better picture, we can change the radar screen to, let's say, 70 miles, so everything is much closer and much better to see. So we can now continue. Okay, unfreeze. KLM 1113, turn left heading 145.
Turning left heading 145, KLM 1113.
Croatia 462, reduce speed to 210 knots.
Reducing speed to 10 knots, Croatia 462.
Turkish 1991, turn left heading 125.
Turning left heading 125, Turkish 1991.
Croatia 5901, speed 210 knots.
Speed 210 knots, Croatia 5901.
Austrian 423, speed 210 knots.
210 knots, Austrian 423.
Now what I'm doing, measuring the actual distance to downwind, aiming to be about 6 miles abeam the final approach fix. Cargolux 122, reduce speed to 210 knots.
210 knots, Cargolux 122.
Now measuring the distance between two in a sequence. It's okay. KLM 1113, turn left heading 100, clear the ILS approach, runway 07.
Turn left heading 100, clear the ILS approach, runway 07, KLM 1113.
Then we have to measure this also. Now as you can see, Santruk is clear, so Santruk can get to 9er. Santruk 404, descend to flight level 900.
Descend to flight level 900, Santruk 404.
Croatia 462, turn left heading 250.
Turn left heading 250, Croatia 462.
Cargolux 122, turn left heading 120, clear to intercept localizer.
Turn left heading 120 to intercept localizer, Cargolux 122.
Freeze. Okay, now you see the traffic situation like this. So, what will we do next? Actually, it's very important. You have always to measure the distance between aircraft turning to final for the ILS. So 6.8 miles, 6.6 miles. It will be good. But actually the most important thing is to keep that distance. How we do that? So KLM 1113 is cleared for the ILS, but it has the speed of 187 knots, so 187 knots. Turkish and Cargolux are slightly higher. The difference is about, let's say, 40 to 45 knots. What that means? So if we have, for example, 45 to 60 knots of difference for a given aircraft, the other one behind in 1 minute will take 1 mile more behind. So this 6.8 miles will be 5.8 miles. So to make sure that doesn't happen, we'll have to reduce those two aircraft to have the same speeds during the approach and same distances. So next thing we have to do is to organize the approach of the others. We see that Croatia 462 is now the number 4 during the approach and everything. So at time being, it will be good to wait Croatia a little bit more and then to turn Croatia a little bit inbound the runway. But at the same time, we have to slow down the Sun Express 6996 and Lufthansa 474. And that is the sequence we are going to make. So KLM, Turkish 1991, Cargolux 122, then Croatia 462, then Sun Express 6996, then Lufthansa 474, and then we will measure who will be the first of these two. Actually, they are on the same. And the very important thing, like I said earlier, you have to measure the distance abeam the final approach track. Why is that important? For example, if Croatia 591 is closer to the runway, and let's say flying at 3 or 4,000 feet, then KLM, if it executes a missed approach, you won't have lateral norm here. It will be less than 5 miles with the same altitude. So it's always important to measure the beam distance and actually to keep the aircraft abeam, let's say 6 or 6.5 and more miles. It gives you the space for turning and it gives you the space for the maneuvering and calculating which one will be number 1, number 2, number 3 and turning at the same time. So the best thing in here is to have all of these on the arrival put together. So you now have the exact point and mileage and turning. So we can now continue. Okay, we can continue, unfreeze. Turkish 1991, turn left heading 100, descend to 3000 feet, clear ILS approach, runway 07.
Turning left heading 100, descending to 3000 feet, clear ILS approach, runway 07, Turkish 1991.
Turkish 1991, reduce speed to 190 knots.
Speed 190 knots, Turkish 1991.
Cargolux 122, turn left heading 100, cleared ILS approach runway 07, leave 5000 feet on the glide.
Turn left heading 100, leaving 5000 feet on the glide, cleared ILS approach runway 07, Cargolux 122.
Sun Express 6996, reduce speed to 210 knots.
Speed 210 knots, Sun Express 6996.
Croatia 462, turn right heading 340, descend flight level 60.
Turning right heading 340, descending to flight level 60, Croatia 462.
Lufthansa 474, reduce speed to 210 knots.
This is speed 210 knots, Lufthansa 474. KLM 1113, ILS established.
KLM 1113, contact tower 119 decimal 9.
119 decimal 9, KLM 1113.
Okay, we can freeze now. Okay, now, as we said, we have now nice distance between Turkish 1991 and Cargolux 122. Almost the same speed for both, and we are giving in the Croatia 462. What do we have to do again? Measure the distance between Cargolux 122 and Croatia 462. So we have 8.3 miles to the final approach track or localizer, and then we measure another thing, which is the distance of the Sun Express between the localizer and everything. So we now have to calculate when to turn Sun Express inbound to get in line with Croatia 462. Good way to do that is if we measure the heading which was given to Croatia 462, that heading leads us actually here. And if we measure from that point, for example, 7.6 miles, let's say, we can calculate the turning heading for the Sun Express. Or we can wait a little bit, and when we turn the Croatia, we can turn the Sun Express. You have quite enough options, but the important thing is to measure all the time. So all the time you have to keep these two combined to give you exactly 6.5 miles, and to keep track of the speeds. Also now the number 3. Between Cargolux 122 and Croatia 462. And then later on we will do it about Sun Express 6996 and Lufthansa 474. If you want, you can even now take the distance between two of them, because they will follow each other to the final. So after 4 of this, you can decide which is number 1 next, Santurk, Croatia, whichever is convenient for you. They're maintaining the same speeds, approximately the same distance. Maybe even Santurk will be in front. One point to remember: Cargolux instruction, Cargolux 122 instruction was given to intercept or clear for the ILS approach and to leave 5,000 feet on the glide. If it's now more convenient to descend Cargolux 122 to 3,000 feet now, then we can do that, because then Croatia 462 can be cleared to 4,000 feet. So we will try to do that now. Okay, now we'll continue. We'll now continue, unfreeze. Cargolux 122, descend to 3,000 feet, still clear for ILS approach, runway 07.
Descending to 3,000 feet, still clear for ILS approach, runway 07, Cargolux 122.
Croatia 462, descend to 4,000 feet, QNH 1015, reduce speed to 190 knots.
Descending to 4,000 feet, QNH 1015, speed 190 knots, Croatia 462.
Sun Express 6996, turn left heading 100, descend to 5,000 feet, QNH 1015.
Turn left heading 100, descending to 5,000 feet, QNH 1015, Sun Express 6996.
Lufthansa 474, turn left heading 100, descend to flight level 60.
Turn left heading 100, descending to flight level 60, Lufthansa 474.
Croatia 462, turn right heading 040, descend to 3000 feet, clear ILS approach, runway 07.
Turning right heading 040, descending to 3000 feet, clear ILS approach, runway 07, Croatia 462. Turkish 19901, ILS established, runway 05, correction, runway 07.
Turkish 19901, contact tower 119er, decimal liner.
419er decimal 9er, Turkish 19901.
Sun Express 69906, turn left heading 080, descend to 3000 feet, clear ILS approach, runway 07.
Turn left heading 080, descending to 3000 feet, clear ILS approach, runway 07, Sun Express 69906.
Sunturk 404, descend flight level 70.
Descend to flight level 70, Sunturk 404.
Lufthansa 474, descend to 5000 feet, QNH 1015.
Descend to 5000 feet, QNH 1015, Lufthansa 474.
Croatia 591, descend to 5000 feet, QNH 1015.
Descend to 5000 feet, QNH 1015, Croatia 591.
Cargo Lux 122, confirm established.
Cargo Lux 122, ILS established, runway 07.
Cargo Lux 122, contact tower 119er, decimal liner.
119er decimal 9er, Cargo Lux 122.
Lufthansa 474, speed 190 knots.
Speed 190 knots, Lufthansa 474.
Lufthansa 474, descend to 4000 feet, cleared ILS approach, runway 07, leave 4000 feet on the glide.
Descend to 4000 feet, clear ILS approach, runway 07, Velcro, Lufthansa 474.
Suntruk 404, turn left heading 110, descend to 5000 feet, QNH 1015.
Turn left heading 110, descending to 5000 feet, QNH 1015, Sunturk 404. Croatia 462, ILS established, runway 07.
Croatia 462, contact tower 119er, decimal liner.
119er decimal 9er, Croatia 462.
Suntruk 404, turn left heading 090, descend to 3000 feet, cleared ILS approach, runway 07.
Turn left heading 090, descending to 3000 feet, cleared ILS approach, runway 07, Sunturk 404.
Croatia 5901, turn right heading 340.
Turning right heading 340, Croatia 5901.
Austrian 423, turn right heading 320, descent flight level 60.
Turning right heading 320, descend to flight level 60, Austrian 423. Sun Express 6996, ILS established running 07.
Sun Express 6996, contact tower 119er decimal 9er.
119er, decimal 9er, Sun Express 6996.
Croatia 5901, turn right heading 020, descent to 4000 feet.
Turning right heading 020, descending to 4000 feet, Croatia 5901.
Okay, we can freeze now. So, as we can see now, we have, let's say, 4 last aircraft on the approach. Lufthansa 474 is not far away, so all the time we are measuring Santur 404, Croatia 5901 and Austrian 423. So all the time, all 3 aircraft should be patched with each other with the QD mic. So all the time you have the information of distance of each other. For example, Santur 404 between Croatia 5901 8.8 miles and Croatia 5901 between Austrian 423 9 miles. Why is that important? It's important to shorten the way of Austrian 423 and Croatia 5901, and all the time to monitor the speeds of each other, so we will have sufficient mileage on the final. So next thing to do is wait a little bit to turn Croatia 5901 to final approach heading and give it a descent, and with Austrian 423 also to wait and give a final approach heading behind Croatia 5901, descent and the approach. And all the time we will keep this distance measuring tool to see the mileage. That will be 5 miles or more in between. So now we can continue until the end. Okay, we can start, unfreeze. Austrian 423, descend to 5000 feet, QNH 1015, reduce speed to 190 knots.
Descend to 5000 feet, QNH 1015, speed 190 knots, Austrian 423.
Croatia 5901 to right heading 060 descent to 3000 feet, clear ILS approach, runway 07.
Premium right heading 060, descending to 3000 feet, clear Dallas, approach runway 07, Croatia 5901. Lufthansa 474, ILS established, runway 07.
Lufthansa 474, contact tower 119er, decimal liner.
119er, decimal 9er, Lufthansa 474.
Austrian 423, turn right heading 040, descent to 3000 feet, clear ILS approach, runway 07. Report established.
Descend to 3000 feet, premium right heading 040, clear Dallas, approach runway 07, Remco Austrian 423. Santur 404, ILS established, runway 07.
Santur 404, contact tower 119er, decimal liner.
119er, decimal 9er, Santur 404.
Okay, we can freeze now. So at the end of the exercise, there's a point to see between all three aircraft on final approach tech established, and the QD mic tool. It says the headings and the distance in nautical miles, which is good and convenient during the final approach to be patched with all the aircraft, so you can monitor all the time the distance between those three aircraft or other. So that's important, and now we can continue until the end of exercise. Okay, continue.
Croatia 591 ALS established 2007.
Croatia 591, contact tower 119er decimal 9er.
119 decimal 9 Croatia 591.
As you can see now, only one aircraft still left during the approach. So thank you all for watching. That will be it for today's demonstration. Hope you learned something new, and I wish you good luck on your future training for becoming the air traffic control. Thank you all for listening and watching.